Spent a couple days looking at exponential growth, and so we're going to take a look at some real-world applications today. Let's start with the warm-up. Excuse me. What does the following equation tell you? Y equals 3 times 2 to the x. Well, from the problems that we've been looking at, you should know by now that 3 is the starting value. We're going to start with 3 of something. The 2 is your percent growth. So this is the growth, called growth rate. And then x is usually some form of time. So to review an exponential growth equation, you have a as the starting value, the first number, b is your growth rate, and then again, x is usually some sort of time. Sometimes you might see an equation that looks like this, y equals 2 to the x. And if I ask you what the starting value is, the starting value here, a, is actually a 1. And the reason that I know that 2 is the b, the growth rate, is because it has the exponent. So if it has the exponent, this is b, and then the starting value would be 1, an invisible one that they don't write in. Okay, so today we're going to look at problems with percentages. So here are the steps. Change the percent to a decimal. If the rate is increasing, add a 1. So let's take a look at the first example. A population of 100 frogs increases at an annual rate of 22%. How many frogs will there be in 5 years? I'm going to underline the important information. We start with 100 frogs. It increases 22% a year. How many frogs will there be in 5 years? So here's what our equation will look like. Y equals, we start with 100. It's increasing, so we're going to do 1 plus change the 22% to a decimal. So to change a percent to a decimal, you divide it by 100. 22 divided by 100 equals 0.22. So divide by 100, it's the same as moving the decimal place over twice. And then it says for 5 years, so we're going to put our 5 as our exponent. Now the reason why we add a 1 is because if it's increasing 22% a year, we take the 100 frogs and we add 22% more. And so the 1 stands for 100. You take 100% of the frogs from the year before and you add 100. All right, and then we type this in our calculator. So if we want to add these together, the 1 plus the 0.22, it's 100 times 1.22 to the 5th power. Here's how you type it in. 100 parentheses 1.22 to the power of, and the power of is this caret key. It looks like the roof of a house, 5, and you can put that inside the parentheses or outside. I usually put outside. And so there will be about 270 frogs according to this model. So y equals about 270 frogs in 5 years. All right, so let's try another one. In 2010, the cost of tuition at a certain community college was $4,300 per year. The tuition increases at a rate of 4% each year. Okay. How much would it cost to attend the university in 2017? Let's first start by writing the equation. So y equals, we start at 4,300. It increases, so you take 100% of the year before plus. It increases at 4% a year. To change 4% to decimal, you divide by 100 or move the decimal place over twice. It's 0.04 to the x. And x is number of years since we started. So if we started in 2010 and we're going to 2017, how many years have passed? Well, that's 7 years. So here's what it looks like. 4,300 times 1.04 to the 7th power. And we'll type that in. 4,300 parentheses 1.04 to the power of 7 for 7 years. And according to this model, in 2017, the tuition would be $5,658.51. So 5,658.51. How much would it cost to attend in 2025? Well, 2025 is 15 years since 2015, so that would look like this. 4,300, 1.04 to the 15th power. Let's type that in. All right, so that would the tuition would be $7,744.06. Okay, so you've seen how we set up the equation. Let's just try a few more. And this will be what you practice today. You deposit $1,500 into an account that pays 5% interest every year. How much money do you have after 6 years? So we're going to start with our starting value, $1,500. It's increasing, so you take your $1,500, so 100% of the year before, plus your 5%, change it to a decimal, so that's 0.05 for 6 years. You can type that in. So 1,500, 1.05. For 6 years, I believe it was. Let me double check. Yep, for 6 years. And if you kept that money in there and didn't put any more in, or didn't take any out, you'd have $2,010.14. How long would it take you to double your money? Okay, so we have to think doubling our money. What's 1,500 if you double it? Well, that's 3,000 equals 1,500 times 1.05 to the 6, well, we don't know how many years. And so here we're solving for x. So this is guess and check right here. We know 6 years is 2,000, so it should be close to 6 years. So let's just guess. I'm going to try 7 years. I'm going to type it in, 7 years, see how close I get to 3,000. So 1,500, 1.06. Let's try for 7 years, and we can adjust. So this is guess and check. All right, so not high enough. Let's try 8 years. Okay, let's try 10 years. Again, we're looking for when does this equal 3,000? Still not enough. Let's try 15 years. Okay, too high. So it's around 15 years. I'll try 13 years. Okay, so 13 is pretty close. Let's try 12. It's probably in between here. Oops. Okay, so I'm going to say it's going to take about 12 years because 11 probably is too small. Okay, so you can say between 11 and 12 years, so almost 12 years, I'll say. So we did that by guess and check. We plugged in until we found a number that was close to 3,000. Okay, 2 more examples. Since January 1980, the population of the city of Brownville has grown according to this mathematical model. X is the number of years since January 1980. What do these numbers mean? Well, this means this is the population in 1980, in January 1980. And the 1 means it's growth. And the growth rate is 22% per year. And I'm wrong, it's not 22%. It's 2.2%. Let's change that. And I know that because I'm moving the decimal place over twice, or you can multiply it by 100. So growth rate at 2.2% a year. Again, to figure that out, you can do the 0.022. Instead of dividing by 100, you do the opposite, multiply by 100, and that's 2.2% growth. What would the population be in 2000 if the growth rate continues at the same rate? So you have to figure out how many years is it from 1980 to 2000. So that's 20 years. So let's type in 720,500 times 1.022 for 20 years. And let's type you in. I'm going to clear this. Doc B will clear this. 720,500. 720, 500, parentheses, 1.022 to the power of, and it was 20 years, Okay, let's talk about what this number means. 1.1134E6. Need to write this down. Okay, so 1.1, I forgot it already. 1.1134E6. It means move the decimal place over 6 times. I'm going to write it up here. I'm out of room here. 1134E6. All right, so 6 places. 1, 2, 3, 4, 5, 6. So this number is 1,113,400. It says use this model to predict when the population of Brownville will first reach 1 million. So that's 1E6. So again, this just means move the decimal place over 6 times. And we know it's around 20 years. It's a little bit less than 20 years. So let's try 19 years. Okay, so 19 years is pretty close. We're looking for 1E6, or a bunch of zeros here. Let's do it again. Oops. And let's do for 18 years. Okay. So getting closer, let's skip, let's go to 15 years. Okay, it's probably between 15 and 16 because this is almost a million. So 720. Okay, so it's between 15 and 16 years. And this is our x value, and x is between 15 and 16 years. All right, last example. A basketball card you bought for $2 increases in value 15% a year. What will the card be worth if you try to sell it in 4 years? Okay, so for this right here, we start with $2. It increases, so it takes 100% of the value of the year before, and we add 15% to that, so plus 0.15. For 4 years, you can type that in. Let's clear this again, doc B. 2 parentheses 1.15, and you're trying to sell it in how many years? 4 years. So you could sell it for like $3.50. It's about $3.50. How long will it take for your car to be worth $50? So you're looking for when this equals 50. So here you're solving for x right here. You're going to plug in and see how close we can get to 50. So we know 4 years is way too little because it's just $3. So let's try, how about 20 years? Okay, 32, so it's more than 20. Let's try 30 years. Too much, so try 25. So again, we're using guess and check to solve and figure out how close we can get to this to be to 50. Ooh, even closer. Let's try 23. Okay, so I'm going to say about 23 years, because if you round up, so between 23 to 24 years. Okay, so you're going to try setting these equations up. You have to know the first number is the starting value, that it increases. You change your percent to a decimal and add 1, and then that we have time. You have to use guess and check to solve for some problems. Some problems you can just plug in.